Hello, this is the first in a three-part series on rational functions. This video pertains to horizontal and slant asymptotes. So there was a previous video on vertical asymptotes, and we'll have a third one that puts everything together to graph a function. So here, a horizontal asymptote, we're looking at a rational function, f of x is equal to p of x divided by q of x. So we have some sort of ratio for our function. And we want to know as x approaches infinity or x gets larger and larger, what's happening to our function? Is it increasing as well? Is it approaching some value? So that's what we're looking at for our horizontal asymptotes. So we have rules for different scenarios. So here we have 6x squared divided by 2x squared plus 1. And you notice the degree of our numerator and the degree of our denominator are both 2. So we have 6x squared, 2x squared. So they're the same. So when that happens, we just are going to take a ratio of our leading coefficients. We have 6 and 2. Okay, so that's 3. So we're going to have a horizontal asymptote at y equals 3. And this is just an illustration of what that function actually looks like. You can see here they're doing some stuff in the middle, but as we get bigger, we get closer and closer to 3. And as we get smaller as well, as we decrease without bound, we get closer and closer to 3. Okay. The next example we have here is 6x squared divided by 2x cubed. And what you'll see is the degree of the numerator is less than the degree of the denominator. And whenever that happens, we have a horizontal asymptote at y equals 0. So here, this is just an illustration of what this function looks like. And you can see it's doing there's some activity in the middle, but as we get larger and larger, we're coming closer and closer to our y-axis, which is our x-axis, which is y equals 0. And as we approach negative infinity, as we get larger and then as we decrease, we're getting closer and closer to this y equals 0 line. Okay. The next scenario is when we have here we have 6x cubed divided by 2x squared plus 1. So our degree of our numerator is 3, and that's greater than the degree of our denominator, which is 2. So in that case, there's no horizontal asymptote. And this is a graph of our function. And you can see there's actually a slant asymptote for this, and we'll talk about what those are in the next slide. But as you can see, as we get bigger and bigger, this is just increasing without bound. And as we get smaller and smaller, we're decreasing without bound. So there's no horizontal asymptote. We're not approaching a specific number as we approach infinity or negative infinity. Okay, so if the degrees are equal, if the degrees are equal, we're going to take the ratio of our coefficients. If our degree of our numerator is less than the degree of our denominator, we have a horizontal y equals 0. And if our degree of the numerator is greater than the degree of the denominator, we have no horizontal asymptote. Okay, so I am going to, hold on just 1 minute. I'm going to clear out my drawings. And, we'll go to the next slide. So, a slant asymptote. We have a slant asymptote when the degree of the numerator is equal to the degree of the denominator plus 1. So if our numerator is 1 greater than our denominator. Okay, so here we have this example, and we have 2x squared minus 5x plus 7, and then we have divided by x. This is kind of like a 1 minus 2. So the degree of our numerator squared is 1 greater than the degree of our denominator, which is just x. Okay, so in this case, we're going to have a slant asymptote. And then we had to figure out how we find that slant asymptote. To find the slant asymptote, we're just going to do the division. And then we're going to take the quotient without our remainder. So what does that mean? It means I'm going to do this. This is x minus 2. And we're going to divide this into 2x squared minus 5x plus 7. So 2x minus 2, x minus 2 goes into, we're looking at our leading term, 2x squared. So we need a 2x. Okay, 2x times x is 2x squared. 2x times negative 2 is minus 4x. I'm going to subtract this. These terms go away. This becomes a positive. This becomes negative x plus 7. And then negative x, this is going to be minus 1. Negative 1 times x is negative x. Negative 1 times negative 2 is plus 2. We subtract this whole term. Our x's go away, and 7 minus 2 is 5. So we have this plus 5 over x minus 2. So this part here, this 2x minus 1, is going to be our slant asymptote. Okay? So when we plot this function, I've plotted here. We're also going to have a vertical asymptote at x equals 2 from our denominator. So I've plotted that in red over here. But this line here is our 2x minus 1. And you can see as we get closer and closer to as we get larger and larger, this is approaching this line. As we get smaller and smaller, our graph is approaching that asymptote line. Okay? So that's that. So we're looking for instances where our numerator is 1 degree higher than our denominator. We do the division. We take the portion of the quotient without the remainder, and that is our slant asymptote. Okay, we'll do another video. We'll put all this together and work on graphing. So if you have questions on beyond just finding it and actually graphing stuff, you can take a look at that video.